Hello, I'm Fauwaz Hanbali with the Water Management Systems Division at HEC. I'm going to talk to you about HEC-DSS and gridded data management. This is the third and final part of the presentation, focusing on HEC-MetVue tools for working with HEC-DSS gridded data. In this part, I will give you some highlights of key features and interactive tools in HEC-MetVue for working with gridded DSS data, from reading and displaying grids to editing and writing grids. So HEC-MetVue is HEC's meteorological visualization utility engine. It specializes in the processing and editing and display of gridded meteorological data. HEC-MetVue also provides inputs for HMS, rainfall runoff and snow melt runoff models, and inputs for HEC-RAS hydraulics models. HEC-MetVue interface is highly interactive, and it gives the ability to view and tile multiple map windows, as well as edit and customize viewing properties, especially color scales, the type of map layers to show, including internet maps. Let's look first at the HEC-DSS selector in HEC-MetVue. The HEC-DSS selector has quite a bit of handy options, in particular read options, that allow for constraining the spatial extents of gridded data to read. For example, for gridded records that cover the entire country, an input shapefile for a specific watershed can be used to clip the extents of the gridded records that are read. There are also time-based filters to select a range of DSS records by defining a time window of interest. And if the HEC-DSS file contains a variety of gridded records with a mix of hourly and 6-hourly and other durations, there's an option to filter by time interval, including a 0 hours interval filter for instantaneous gridded records. The HEC-DSS selector also has very convenient options for gridded record filtering in the cataloging section. That's in the lower part of the editor. The A through F part filtering fields are a combination of a drop-down list and string-based searching, including the use of wildcard characters. When reading DSS gridded records, HEC-MetVue takes the time sequence of those gridded records and aggregates them. That's to display a statistic grid. So typically for precipitation gridded records, HEC-MetVue would compute and display the cumulative precipitation grid for the selected time window. For temperature gridded records, HEC-MetVue would compute and display a period average grid, or the maximum or minimum grid over the period, whatever the user chooses. And given a polygon shapefile like a basin map, HEC-MetVue can compute and display a default basin average layer, which is based on the intersection of gridded records and the areas in the shapefile. The user can still scan through the individual DSS records by turning on the dynamic time window scanning and animation tool. This tool is very interactive. It allows for the autoplay of the animation or direct interaction through the slider bar controls. There's also the ability to sample time series directly from the map window by using the draw tool to specify a point or multiple points over the gridded data, and then plotting the time series for each point. Like you see in this display for the 5-day precipitation grid for Hurricane Florence, sampling time series from the aggregate grid is particularly helpful to see the temporal variation of the gridded records for the different point locations. And HEC-MetVue can be used to create interpolated gridded records. Its MetInterp tool takes georeferenced DSS time series records and generates spatially interpolated grids. There are 4 interpolation methods available: the inverse distance and inverse distance squared interpolation methods, and the nearest neighbor and bilinear methods. A variety of DSS data editing options are available in HEC-MetVue. Measurement values can be adjusted for the entire extent of the gridded data set, or they can be adjusted for an area of interest, delineated with the draw tool. They can also be adjusted for a single grid cell point. There's an edits tracker that allows for exporting a log of edits in either a text format for documentation purposes or a script format for importing and recreating the edits. And more importantly, the edits tracker allows for undoing, redoing, or clearing edits. Another feature for editing DSS gridded data is through the zonal adjustments editor. Zones can be created from polygon selections in the shapefile. For example, a basin can be divided into upper, middle, and lower zones with respective subbasins assigned to each zone. Then through the zonal editor, adjustments and edits for any specific time can be applied for a group of grid cells that fall within each zone. And writing out HEC-DSS records as possible from HEC-MetVue. One could output a spatially clipped version of the input data set, or output resampled resolution of the grid set, or output a modified version of the input data set with adjusted measurement values. The Save tool also includes options to time shift the output. So this can be particularly handy for generating test data or for generating surrogate forecasts based on historic data. Finally, many of the features in HEC-MetVue can be scripted. There's a variety of command line utilities to automate HEC-MetVue operations. Just to highlight a few, there's the ability to automatically translate NetCDF and GRIB and other data formats into HEC-DSS and automate the computations of aggregate statistic grids or time series basin average computations. And there's the ability to automatically apply adjustments to grids, and reprojecting them can also be automated in addition to generating interpolated grids from point time series measurements. This is the end of the HEC-DSS gridded data management presentation. If you have any questions about our software, need some help, or looking for additional training, please check out the links below, and thank you for your time.